What's my go-to way? It's not to build it this way. My go-to way when I'm first using the cubes is to build it this way. Everybody good with this? Go like this if you're like, I get it. That's a good way to build one group of 13. Go like this if you're like, that's a good way to build one group of 13. Do you really see 13? It's 13. Then I say to kids, is it 13? You know what I see on Zoom? Every kid goes like this. Why are they all leaning forward? Because they're about to start what? Counting it. Do I want that? Everything I'm doing is to get kids to what? Stop counting. Think in groups. I would never build 13 that way. This does not encourage base-10 thinking. It does not encourage grouping. It doesn't encourage expanded form. It encourages exactly what the problem is for so many kids, counting. Would this be better? Am I allowed to even say better? How do you know there's 10? Well, would this be even better? Especially if I know kids are weak at number lines. There's so many ways you can combine your teaching to address all the problems we see at the upper grades in elementary and middle school and high school. Just got to do it. I don't want counting, so everything humanly possible I'm going to do so they don't count. If I didn't have a number line, everybody close your eyes, close your eyes, close your eyes. When I say go, show me immediately with your fingers. Immediately. If you don't do it immediately, you're cheating. Ready? When I say go, show me with your fingers. How many? Ready? How many green ones? Go. Show me. Go. Right away. Go. Very good. Did anybody say 10? Oh, like this if you said 10. Is it easy to trick you? Of course. We can't subitize reliably more than like 5 or 6 as a human. So if you keep modeling things where it's like 9 things on your desk or 9 things on a table or all lined up in a row, you're doing the kid a disservice. So if I don't have a number line, well, if I had a number line, wouldn't it have been easy as heck to see it was 9 like that? But if I didn't have a number line, I wouldn't put it out there. I go like this. And if the kid had a good kindergarten teacher, would they know that's 9? Because isn't that a base 10 with a 10 frame with 1 missing? Yeah. And we talked about this last time. If you want to develop higher skills, don't always show it that way. Because this is what I want the kid to know by 3rd grade. You start focusing on equal groups in pre-K, K1. You lose nothing. You gain a ton. This is what a curriculum should be doing for them. Okay? It should be developing harder skills in an age-appropriate way earlier. Everybody okay with this? Now, can I make 13 if I have Unifix cubes on my desk like that? Yes. Can I do 13 if I have flat circle counters like that? No. Then don't do it that way. And if I want 3 groups of 13, would I build it like this for my kids? Be honest. Is there anything appealing about that? Anything? Yeah, it's more colorful. Yeah, there's a lot appealing about it. But math-wise, is this better or worse? I think it's a little bit worse. I don't want that. So if I say, oh, group the 10s, yeah, they're the same length, but do you think a little kid sees color before length? I do. So they might see the color way before the length. Now, what if I did stuff like this that I also see? Do you like that even less? Yeah, because the kid, I say, oh, what goes together? Can the kid easily put that with that and that with that? Yeah, we're trying to cut through all the things that they might do that we don't want and make it easier for them. Common sense ways, not fancy math ways, just common sense. So again, if I'm going to do it, I'm not going to pick red and orange because if the kids are slightly colorblind or whatever, if possible, you'd actually pick your 10s and 1s on opposite sides of the color wheel. That's what you would really do. Everybody okay with that? So again, I might even do something like this. And if I did that, do you think it's more likely that kids would naturally see that they're equal and naturally come to the distributive property by themselves? So what would I want the kid to do? Maybe if you believe in CPA like I do, instead of always just doing the C, then doing the P, then doing the A, do struggling kids ever have trouble with the transition from one to the next to the next? It's the bridge. So we've handled that in different ways. One of the ways is I have selected the C I want, the P I want, the A I want, because there's multiple C's, multiple P's, multiple A's for everything. For our program, I picked them with an eye towards the upper grades. So I could easily have picked circle counters for K and everybody's happy. They're happy until what? That kid has to take 6th grade math. Then the 6th grade teacher's not so happy. How many of the programs really have an eye towards the upper grades? I don't see it the way they're teaching. Too much counting, too many of the wrong manipulatives, too much they're not doing it the way I would do it if I had an eye towards the future. So here's the C. It can be real Unifix cubes. I could be modeling it virtually, and they all got real ones on their desk. So every kid has a mat with the number line on it, and they have their cubes, and they're modeling exactly what I'm doing. Everybody okay with that? And then eventually, could they transition to doing it digitally? Yeah, they could. You decide when's the right time. Well, there is a right time. It's not never. I promise you that. You can do so many more problems when you switch to digital. Practice as a student. What could the kid be doing? There's a misconception about those two models. Does this mean literally a picture of the concrete model? In too many programs and experts' minds, that's what they think. So they start with base 10 blocks, and guess what they have the kid doing now for weeks and weeks? Drawing base 10 blocks, because that's what they think a picture means. It does not. It can, in a very limited view, you can think of it that way. I think this is a progression. We go more abstract in this direction, we get more concrete in this direction. It's a continuum. I can have abstract concrete models, and I can have very concrete models. Everybody okay with this? Okay, so what might I have a kid be doing while I'm doing this? I don't want them to draw all the unit cubes. What could they be doing? Could they draw this? Could they do that? They could. That's the kind of way. Is this like a bar model, a tape diagram someday that they should have been doing starting in K and 1? Yeah, by 3rd grade, if this is grade 3 to you, 3 times 3 groups of 13, this should be nothing. And then the question is, when you look at this, give me a thumbs up or thumbs down. Do you see equal groups? And what makes it easy to see equal groups? I'm using a length model, not an area model, not counters. Got to be focusing more on length models first. Okay, so this is equal groups. Everybody said they saw equal groups. Do you see an array model? So far, I picked a model that you can see equal groups and an array. So all the people, all the programs you see that are showing fruit over and over because they love glossy photos because it's more marketable. All you see is people putting up fruit everywhere because they're all about marketing. So they have all these nice looking fruit like this. It's the wrong model to focus on. It's complete. I see 3 groups of 5. I don't see 5 groups of 3. I see equal groups. I don't see an array. I can't get to the area model. In my mind, don't want it. Don't want it. You might do it to make it interesting for like 5 minutes, but I'm not going to do it as my go-to model. I'm not going to buy a program that's doing that for your, to develop your thinking. Now, everybody said they saw equal groups. Everybody said they saw arrays. Do you see an area model? Yes or no? Do you see an area model? Everybody I know from before is going like this, and people that I don't recognize, some are going like this, some are going like this. I don't know. You see an area model? What do we say area cannot have? Show me. What can area not have? And now everybody's going, you can communicate your thinking without speaking. That's how I teach 7,000 kids at a time. Some of ours were up to 15,000 kids during the pandemic. We had 15,000 kids coming routinely during the pandemic. But is it very simple to turn it into an area model? It takes like 2 seconds. Why wouldn't we be standardizing on Unifix cubes? Is this a concrete model? What would be a pictorial model? You want your kids at their desk going like this? How long is this going to take? No, I don't want that. If they need a concrete model where you see all the unit squares, guess what? Let them use the cubes. What could you go to instead? Could you literally talk about geometry? It's a rectangle. And do you see 2 parts in this rectangle? And does it help that I made the 10s all the same color and the 1s all the same color so that I clearly see 2 parts? Could the kids start going like that? And I could say, well, what's the length of this side? Now, tell me about length. We can measure length in units. What can the units not have in length? Anytime you measure length, what can the units not have? Gaps or overlaps? What can the unit squares not have when you're measuring area? Gaps or overlaps? What can unit cubes not have when you measure volume? Gaps or overlaps? Everybody see like how consistently we could be speaking throughout the grade levels. That's foundational about measurement. So do you see gaps in here? No. If I go like this, can I say the length of that side is 3? No, it's not 3. Can I say the length of this side right here is 13 if they all look like that? No, I can't. This is very common sense. I don't think kids go, oh yeah, that makes no sense. No, it makes perfect sense to a kid. To most. Ready? So what would the kid draw now? 3, 13. And what are they breaking the sides into? That. And do you see the distributive property clear as day? You may not know the word distributive property. Who cares? There's time for that. Now, thumbs up or thumbs down? Concrete. Thumbs up or thumbs down? Pictorial. As you get older, could this be the concrete model? Yes, that's one of the most important messages of today. People have this notion that concrete, you have to be able to touch it and work with it. Not true. As you're younger, I think that's true. You want very concrete manipulatives. But if you're okay with this being concrete, as I get older, I can't touch it. It's digital. It's more abstract, but on the continuum, I could, as you get older, still call that the concrete model. Could I call this a pictorial model? Yeah, it's more abstract than that. That might be the progression. I get a little older. Do you clearly see I'm breaking the 13 into 10 and 3, especially since I have it on a number line? Do you clearly see I'm breaking the length 13 into 10 and a 3? Do you clearly see I'm breaking the 13 into 10 and a 3? Who can write it abstractly now? What would be the progression after that? Somebody wrote this, and that's true. That would be very abstract because for that to make sense to me, I'm trying to show the 13's a 10 and a 3. Is there anything that they wrote here that clearly shows me that I'm thinking of the 13 as a 10 and a 3? This is more about what? The operation, like getting to the answer, which is fine. Now, if the person had done something like this, would that kind of do maybe more to show me that it's a 10 and a 3? Maybe, maybe not. Somebody wrote this. Is that an abstract way to show 3 times 13 and the 13 is a 10 and a 3? And what did the person just get us to? The distributive property. Now, we talked about this last time. I build this throughout my program. A lot of my problems of the day that I'm writing for every grade level, every lesson, I'll have a problem of the day that you could use for exploration, assessment, whole class, small group, independent practice. I try to always emphasize 2 things consistently in my program. What's the right answer and what's the number 1 incorrect answer? Who can tell me the number 1 incorrect answer for this? If you teach middle school, you know. And that guy who looks like a math teacher did it immediately. You know what he said immediately when I say, show me the number 1 wrong answer? Immediately, he did that. Does everybody see where that came from? Anybody who is taught middle school knows that's the number 1 wrong answer. What did the kid not do? Distribute. Like that's one of the most important things we can teach in grades 3, 4, 5 of elementary school is the distributive property, and you don't even have to call it the distributive property. But what does the kid do here? They did the 3 times the 10, and then they added the 3. Is everybody good with that? And if I go to middle school in any district and I see the distributive property is a problem, am I down on the middle school teachers or am I down on the 3, 4, 5 teachers? I know they had 3 full years to teach the distributive property and they didn't get it done. It's not a finger pointing thing. It's just, if you care about these kids, we got to fix it.